Everyone. In this session, I want to talk about the neural networks. So, initially, we will spend some time discussing the conceptual aspects of neural networks, and after that, we'll take an example data set and try to apply the neural networks for that particular data set, do the necessary interpretations from the data set, right? So that is how we will go ahead. But let me tell you here with a word of caution in the beginning itself that neural networks is a kind of very complicated, complex kind of a topic, right? And it is based on various mathematical transformations. So the conceptual aspect of it in general is much heavy in case you don't have a proper background in mathematics. But at the same time, because of various technologies like R, we can directly use these neural networks for our business prediction purposes. So, as an applied user of neural networks, I can comfortably use them for prediction purposes or for classification purposes. So I can very well use the concept of neural networks because tools are doing the job for me. But if I have to get the mathematics behind it, then probably I need to have so many concepts in mathematics clear. So here the focus is just to give you a broad outline of those mathematical concepts, with the major focus being how are these neural networks actually used for the prediction purposes. So that's the major objective here. So probably you can say that we would treat neural networks majorly as a black box, while some amount of basic understanding would be provided, but still as a black box for executing a business solution for a prediction problem. So that is how I am going to look at the neural networks per se. So initially we will talk about why to use neural networks, when to use neural networks, what are neural networks, etc. Then we would try to link in the concept of artificial neural network. How does it work? And some of the major components of this artificial neural network, wherein we have to understand what is this activation function, what are the different types of activation functions are there, and how does my prediction change with the change in the activation function. So we can understand all these aspects out here. Then how are the neural networks typically built? So the architecture of the network, otherwise we call as the topology. How many layers are there as a part of this network? What goes into what layer? So we are spending some time in terms of understanding the network topology. Then how do we really train the neural networks? We talk about a process called backpropagation. So using this backpropagation, how do I really train the neural networks? So these are some of the conceptual aspects that we are going to work out with before going ahead in terms of taking up an example data set and implementing neural networks on that data set, using that for the prediction purpose. So here I wanted to bring in something more. We will take one single data set, right? We will try to do, so this data set, the objective is numerical prediction. So we'll try to, we know that we can use regression models for doing that numerical prediction, or we can very well go with regression trees, we can go with model trees, or now we can even look at neural networks. And probably in the next session I'm going to bring in the support vector machines. Even the support vector machines can be used for predicting a numerical data. So what I really want to do is I'll take a data set Quickly, I'll try to execute these three which we have already dealt earlier with the same data set. And we would also do the neural networks on the same data set. Try to see how each one of them are really improvising the solution for this particular data set, which solution looks more and more appropriate, etc. Right? So that's what I want to see, and probably when I'm discussing the next session on support vector machine, I want to take the same data set and I want to extend the example as well. Alright, so let's get started. So what is typically seen is neural networks is one of the most powerful machine learning algorithms in the today's world, because the applications of this neural networks, they are across several domains. I can use them in finance, I can use them in behavioral sciences, I can use them in humanities. There are wide varieties of areas. In science, I can use a lot of neural networks. So there are applications in many domains across different kinds of tasks. So that's one of the main reasons I can really vote for neural networks as the most powerful kind of a machine learning algorithm. But it's primarily a black box. Very difficult for me to understand the way the model is getting constructed. The workings of that model are very difficult to understand. The calculations what are typically done as a part of the neural networks are very difficult to understand. So if you try to understand the mathematics, it is a very complex mathematics. So unless I have a very good hold in mathematics, the advanced mathematical concepts, I cannot really understand the calculations of neural networks. But functionality wise, business wise, whenever we are using the word a neural network or otherwise artificial neural network in detail, we are again modeling a relationship between an output, generally which is a dependent variable, and a set of independent variables which are typically called as inputs. So here we use the word signals. Output signal is more like a dependent variable, and we are trying to build relationships between a set of input signals, which is a set of input variables, and one output variable, which is a dependent variable. So more or less we have seen regression also does the same purpose. Regression tree also accomplishes the same. Model tree is also designed for the same purpose. So you could see here building the relationships. So even the classification models, even they do the same. We are trying to build relationships between output and a set of inputs. So all these come under the supervised learning processes. In short, if I have to put, these all are a part of the supervised learning processes itself. So when it comes to neural networks, they are very versatile learners. Almost any kind of a learning task can be accomplished through neural networks. So if you see till now, whatever the various sessions that I have dealt, in the supervisory learning, we said two broad forms. One is classification models, one is numerical prediction. Under the numerical prediction, till now we have looked at these three: regression trees, model trees, etc. Under the classification, we talked about nearest neighbors, right, naive Bayes, and we also looked at decision tree, classification rules. These all come under the classification model. These all come under the numerical prediction model. But the neural networks, I can put them into either of them. And in some cases, I can use neural networks for unsupervised also. These are one such kind of technique which are typically used both for supervised as well as unsupervised kind of learning processes. So that's one more advantage associated with the neural networks. So when the relationships between the input and the output are very, very complex, I can very well think of using the neural networks for modeling the relationships between the inputs and the outputs. So that's the basic background behind the neural networks. Now coming to the basic concept of the neural networks. So basically it's a diagram. If we are talking about any kind of a network diagram, so we are trying to link or put a relationship between different inputs, right? In general also, we are talking of different inputs, mapping it to a particular output. So we have several input variables in this diagram. I have three input variables x1, x2, x3, and I have an output variable y, right? So when I'm talking about a network diagram, I'm trying to build relationship between x1, x2, x3, which are the input variables, and an output variable which is y. You also see here I'm giving some kind of weights w1, w2, w3 to each of the input variables, right? The reason why I am giving the weights is, even if you look at the human being, human brain trying to understand any particular input information, I try to give some weight to some information, I try to give very less weight to some other information. So that's the same way, different inputs that are being supplied to it, they are carrying different kinds of weights. So if I am having three different inputs, three different weights are being assigned to them. So some of them will contribute more to the overall information, some of them will contribute lesser. But right now there is again a mechanism which the system will use to determine W1, W2, W3. But for now you just try to understand that there are different weights that are associated with different inputs. And so which means to this, at this stage, the information that comes out is W1x1, W2x2, W3x3. Now this particular signal that is coming